And so this can actually explain a few things that sound intuitive. It explains that why perceptual illusions and hallucinations are more common when the sensory input is noisy and imprecise. For instance, in whispering crowds or the dark corners of the periphery of our vision. So when there's a lot of uncertainty, when the precision is expected to be low, the top down inferences take over. The top down predictions take over, and that is more classically thought of as hallucination, because there is no the input has been from lower levels have been dampened down, and the top down predictions taking over. Okay, I'm just returning to this hierarchy once more to just show where this neuromodulation can take place, and these red arrows, those then are inputting onto the prediction error units, and they can either turn up the gain or have low gain. And if there's if it's expecting high precision, it will then turn up the gain and send those prediction errors straight up to the top of the hierarchy. If there's low expectation for precision, then those top-down predictions are gonna take over. So there's one last part for this video, which is on attention. So prediction processing has something important to say about attention, and one of the slogans that's found in both Surfing Uncertainty and the Predictive Mind is attention is nothing but optimization of precision expectations. It's a little bit wordy as a slogan, but what it means is that the focus of our attention is a way of us to sample data that we expect will be precise, and in doing so we turn up the gain on the prediction error units in that region. So another way of putting this is that we sample the world for precise sensory information that will help us prove our current hypothesis about the world. And if there's a prediction error, this error will be propagated to the highest areas of the brain because of the high gain on the prediction error units. And this propagation of prediction error will then result in a revision of the current hypothesis. So it kind of means, when we're focusing on things, when we're looking and we're being attentive, hearing out for something, what's happening here is that we are sampling the data that we think is most precise. We're turning up the gain on those units, and then we can then revise our hypothesis if it's not what we expect. Okay, so in the next video, I'm going to talk a little bit about how this turning up the gain or the changing in precision expectations can go wrong, and what implications this might have on the neuroscience of different mental illnesses.